Hey everybody, welcome to another con support video. This one's on probabilities of compound events. Okay, so it says you've decided you want to plant. Oh, sorry, I can't read. You've decided you want a plant for your room. At the gardening store, there are 4 different kinds of plants: tulip, fern, cactus, and ficus, and 4 different kinds of pots to hold the plants: clay pot, plastic pot, metal pot, and wood pot. If you randomly pick the plant and the pot, what is the probability that you will end up with a tulip in a plastic pot? So I don't know why you'd randomly pick this, but if you did, hey, why not? So the first thing you have to figure out is this is a compound event, which means, and remember in probability, the idea of and means multiply, right? So when you see and in probability, you guys should think multiply. All right. So we want to have a randomly selected item. Okay. So we're really talking about the probability of a plant and the probability of a pot. So this is a probability of a specific plant and pot. Okay. And the one we're looking for is probability of tulip and plastic. So this idea of and means that I'm really going to do the probability of getting the tulip, and I'm going to multiply that by the probability of getting the plastic container. So it's probability of tulip times the probability of plastic. And in terms of the plants, right, there's 4 different kinds of plants: tulip, fern, cactus, and ficus. So what's the chance of getting the tulip? It would be 1 out of the 4. And there are how many different types of pots? It says there are 4 different kinds of pots, right? The clay pot, plastic pot, metal pot, and wood pot. So that's also a 1 out of 4 chance of getting a plastic. So it's really just 1/4 times 1/4, which is 1/16. So the answer here is literally just 1/16. That's how easy it is. You don't need to make a table for this. You don't need to make a tree for this. Just multiply the 2 probabilities together. Okay, next up. If you roll 2 fair 6-sided dice, what is the probability that the sum is 4 or higher? Okay. So this one requires a little more thought because you have to think about all the ways you can make a sum of 4 or higher. So it says 2 fair 6-sided dice. I'm just going to write out a little table for this. You've got event 1, which is going to be, I'll call it event A. This is the first dice. 1, 2, 3, 4, 5, and 6. You've got event B, which is the second dice. You get a 1, a 2, a 3, a 4, or 5, or a 6. These are equally likely, so we can do it just like that. And then I'm going to change to a different color for the interior here. And we're looking for the sums, right? So, 1 plus 1 is 2, and then the 3, and then 4, and then 5, and then 6, and then 7. And then you can just add these together and get 3, 4, 5, 6, 7, 8. And add these together, you get 4, and then I get a 3 and a 2 on a dice, that's a 5, a 3 and a 3 on a dice, it's a 6, 3 and a 4, it's a 7, and so on and so forth. So I'm just going to fill this out really quickly for you guys so you have all possibilities. So this is all the sums that could occur and how they could occur. And one last row. Okay. So we're looking at all these possible sums. It says, what is the probability that the sum is 4 or higher? So that includes 4 or higher. So we're looking for anything that's 4 or higher. So obviously that would be this, this, this. These are all 4s, right? And then anything that's higher than that would be all this stuff, right? So there's really only these 3 things that are not kind of 4 or higher. Just the 2, the 3, and that's it. So a sum of 2 or a sum of 3 are the only things that are not 4 or higher, right? So how many of those do you see? So if I change the color to, like, let's say green, we could say these 3 are the only ones in green that are less than 4 as a sum. So that means that the probability of 4 or higher is everything else. Well, how many things are here? Well, it's 6 by 6, so it's 36, right? So there's 36 outcomes that are possible. So that's the whole, 36 out of 36. You're going to take away the 3 that don't work, so take away 3 out of 36. And you're going to be left with the number of things that do work, which is going to be, in this case, 33 out of 36. Now you can simplify that, you can make it a percent, but I don't think Con cares about that. So I'm just going to put in 33 divided by 36. Okay, James lives in San Francisco and works in Mountain View. In the morning, he has 3 transportation options: bus, cab, or train to work. And in the evening, he has the same 3 choices to come home. If James randomly chooses his ride in the morning and in the evening, what is the probability that he will take the same mode of transportation twice? Okay, so this one's a little, a little bit, I don't know if it's tricky. It's not really tricky. It might be very straightforward. But you could make a table for it if you were feeling a little confused by it, or you could probably just do this multiplication. But basically, if you wanted to make a quick table for it, it's pretty easy. You'd have what? You'd have event A, which is the trip to work, and it would be, looks like the 3 things are what? Bus, cab, or train. So I'm going to say bus, cab, or train. And then you've got event B, which is the trip home, okay, which is going to be bus, cab, or train, B, C, T. And then you've got all these kind of places where they're going to be kind of overlapped, right? So I'm just going to kind of go in here and, I'm not going to waste my time making a beautiful thing. I'm just going to kind of draw straight. Okay, that's good enough, guys. And we can kind of get a sense of these different sections, right? So let's just kind of close the section off here. Let's just do this. Why not? So here's your table, real rough table. And we can kind of close this off as well. And we can close this off. And if you want, we can even go down here and close this off. So it's the same size. All right, so we got a little table we made, right? So let's see what happens. You got bus and bus. You've got bus and cab. Let's do it this way. Let me kind of go back, and I'll just do the quick way. Just go down with B's. So I was A go down, and then B go across. That's just a really quick way to do it. So the first value is the A's, and the second value is the B's. So B, 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 and then C, 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 and then T, T, and T. Okay, so it says, what's the chance that it's going to be the same? Now, we can see clearly that here's bus and bus, here's the cab and cab, and here's train and train. Those are where it's going to be the same, so it's 1/3, right? 3 out of 9. So that would be the answer. Now, if you didn't want to make a table for it, I don't think you'd have to in this case. You just say, oh, it's 1/3 chance that's going to be each of those in the first one, 1/3 chance in each of those in the second. So that means it's going to be 1/3 times 1/3, which is also, actually, you know what? It doesn't work that way. Yeah. I wasn't really sure that it would work with the and it doesn't. So if you multiply 1/3 times 1/3, you get 1/9. It's not 1/9, it's 3/9, right? So it's a good thing we made the table, right? So I thought I wasn't sure about that and being a right fit. This was one where we wanted the tables to see all the possibilities. Because you could have bus and bus, you could have cab and cab, and you could have train and train. 3 different ways they could be the same. So it'd be 3 out of 9. It's a nice table we made here, huh? All right. There's that. Sometimes you need to make a table to see more clearly. Sometimes you don't. You have to think about whether you feel comfortable with just the idea of the and working on its own as multiplication. Sometimes it's clear, sometimes it's not. If it's not clear, make a table. All right, if you flip if you flip 3 fair coins, what is the probability that you'll get all 3 tails? Okay. So they're flipping 3 fair coins. This is basically a tree. So you make a tree for this. And you want all 3 to be tails, right? Now, what's the chance of flipping a coin? 1 out of 2. So if you flip 3 coins, you're looking at a total possibilities of 2 times 2 is 4 times 2 is 8. 8 possibilities. How many of those would be all 3 tails? Probably not that many, right? Probably 1 out of 8 is my guess. If you're not 100% sure what that would be, then you would just make a table for it. So this is what the table would look like. You're going to split first coin flip, heads or tails. Then you're going to split second coin flip, heads or tails. Heads or tails. Then you're going to split the third coin flip, heads or tails. Third coin flip, heads or tails. Third coin flip, heads or tails. And third coin flip, heads or tails. So this is your first coin flip. This is your second coin flip. This is your third coin flip. And then you're going to go through and analyze all the possibilities, right? Heads, heads, and heads is one outcome that's possible. Now, if heads, heads, and heads happens once, guess what? My guess is that tails, tails, and tails only happens once. Tails, tails, and tails. Only one path. So that's going to be all we really need to do if we don't want to analyze it further. It's going to be 1 out of 8, right? There's only one tails, tails, and tails. Everything else is somewhere in the middle, right? So you have heads, heads, and tails, and you could keep doing this for the entire tree diagram, right? Heads, heads, and tails, You can do heads, tails, and heads, or you could do heads, tails, and tails. You guys can see that everything else is somewhere between these two, right? So you're going to only have one outcome, that's tails, tails, and tails. So all three tails, that's only going to happen 1 out of 8. And that's how you do it. Okay.